Good evening, beta. So today I am starting single slit diffraction. I will discuss Michelson interferometer a little bit later. So today I am going to discuss a topic single slit diffraction. So first question is diffraction. What is the meaning of diffraction? So here, if you are having a slit, okay, this is a slit whose width is E. So what is the width of the slit? Suppose width of the slit is E. And if the size of the slit is of the order of lambda. So what is the condition? Condition is size of the slit E. This should be of the order of the wavelength of the light. So what is E? E is size of slit. Size of slit is E. And this is of the order of lambda. Then what you are going to find out, if you illuminate this slit by a planar wavefront, if planar wavefront is incident on it, then what you are going to find out that that the light after passing through this slit, it will enter into the region which are uh, try to understand here. Okay, if light is traveling, what I'm saying, if light is traveling in the straight line, then light should follow this path, straight line path, and it should enter only into this region. So if a planar wavefront is incident on the slit, then this light, if it is traveling in a straight line, it is undergoing rectilinear motion, then it should illuminate this screen in between A and B. But what you are going to find out, if size of the slit E is of the order of lambda, then then light will enter into this region, which was earlier, ठीक है ना, which was in which light should not enter. ठीक है, here this was the dark region, this should be the dark region. If we are assuming that light is traveling in rectilinear motion, ठीक है, light is following rectilinear motion, that then in this region and in this region you should have dark region. You should have dark. Here it should be bright. But what you are going to find out, if this condition is satisfied, then light is bending here at this position and it is entering into this region. ठीक है, it is entering into this region. So what I am saying here, when light is passing through a slit or an obstacle whose size is of the order of wavelength of light, it will enter into the region, ठीक है ना, which was considered, ठीक है ना, which was considered dark, if we assume that light is traveling in rectilinear motion. Light is following rectilinear motion, then this region should be dark. Okay, this region should be dark. But what we are observing a pattern here. We are going to observe a pattern here. So light is entering into this forbidden region. Into this forbidden region, if size of the slit is of the order of wavelength of light. So this bending of light, okay, bending of light at the aperture or the slit whose size is of the order of wavelength of light, this is called as diffraction. This is called as diffraction. Okay, so that is called as diffraction. So first, there are different cases for this diffraction, like single slit diffraction is there, double slit diffraction is there, n slit diffraction is there. So right now I'm going to consider single slit diffraction. So how can you explain how light is going to enter into this region? It is going to have a pattern. Intensity is going to vary in this region. How you can explain? For this purpose, what you are considering here, you will consider that this slit is made up of large number of point sources here. So this slit is made of large number of point sources. ठीक है, in case of Young's double slit, you was saying that slit was very narrow. ठीक है, you was saying that a point slit was there. ठीक है, point slit was there, or point source was there. S1 and S2, they were considered as the point sources. ठीक है ना, point sources. So if they were point sources, try to understand, then this type of wavefront will be emitted. This type of spherical wavefronts, they are going to be emitted from this source S1. S1. But here, size of the slit is of the order of lambda. Then you can say that this source, this slit, is made up of large number of point sources, and each point source is emitting its own wavefront. So here, in this case, you can consider like this. Suppose this is the slit here, and this is one of the point source. Then it is going to emit its own wavefront. Okay, this type of wavefront. If you consider second point source, then it is going to emit its own wavefront like this. If you are considering third one, third point slit, then it is going to emit its own wavefront pattern. And these wavefront pattern, they're moving in the forward direction. So what is happening here, if size of the slit is of the order of wavelength of light, we can consider that this slit is made up of large number of point sources, and all these point sources, they are going to emit their own wavefront. So now when these wavefront are going to propagate in the forward direction, they will overlap, and as a result of overlapping, you are going to get a pattern on the screen. So this region which was earlier considered as forbidden due to the rectilinear motion of the light, now when you are considering the wave nature of the light, then what you are going to find out, due to this type of wavefronts, ठीक है ना, light is going to enter into this forbidden region. So you are going to get a pattern here as well as here. So why you are getting this type of pattern? Because here, when light is undergoing diffraction, it is following the wave nature. Every point of this slit is acting as a point source which is emitting its own wavefronts. ठीक है, pattern of, and when these wavefronts they overlap over each other, then in this region you are going to find out the intensity. These are the forbidden regions in which you are getting the intensity pattern. ठीक है, so it is the wave nature that is responsible for the diffraction of the light. And what is necessity is it should not be a point slit, it should be of the order of lambda, so that it can be considered as made up of large number of point slits. ठीक है, so in this way this will be. Now, how mathematically, what type of pattern we are going to get here, what will be the mathematical expression, and what will be the shape of the pattern, now we will try to understand that. So for this purpose, first consider this single slit here. This is single slit here. Single slit here. And it is illuminated by a planar wavefront. A planar wavefront is incident on it. This is planar wavefront that is incident on it. This is the original direction of the light in which this planar wavefront is propagating. ठीक है, you place a screen here. ठीक है, you place a screen here, and on this screen we want to find out the pattern. So what you do here, from here, ठीक है, you can consider any one of the direction. ठीक है, any one of the direction. So suppose I choose some theta direction, arbitrary direction theta, and I'm considering the light that is propagating at this angle theta. Theta. For this purpose, I choose two extreme rays. One of the ray will be this, and another will be this. ठीक है? So from here, a part of the wavefront from this point is propagating in this direction. I consider this another point source, this one. These are the extreme point sources which are emitting their wavefronts. And I'm considering the part of the wavefront that is traveling at an angle theta with the horizontal line, with this line, horizontal line. So I'm considering this part. And try to understand in between these, there are large number of point sources. So from every point source, you can consider many point sources. From every point source, you can consider the part of the wavefront that is propagating in this direction. So I'm considering the part of the wavefronts which are emitted from this single slit. Single slit is considered as made up of large number of point sources. These point sources are emitting their own wavefront, and I'm considering the part of all these wavefronts which is propagating at an angle theta, and they are moving parallel to each other. They are moving parallel to each other. So where they are going to overlap with each other, they are going to overlap. You can consider at infinity. If you consider only this part, they are moving parallel. They are moving parallel. So these parts of the wavefront, they are going to overlap at the infinity. But I want to have the pattern on this screen. So what you do, you place a convex lens. So if you place a convex lens here, very close to this slit, ठीक है ना, you are going to place a convex lens like this, and you place the screen at the focal length of this convex lens. What will be the separation between this screen and this lens? That will be equal to f. Now these parallel beam of light, you can say, that is passing through this lens. So what will happen? This convex lens, it will converge them into its focal plane. This is the focal plane of this lens. So all these waves, they are going to focus here. They are going to focus here at this point. It is like this, and you are going to get an intensity here. This is an arbitrary point P, and I'm saying intensity at this arbitrary point is IP. I'm interested in finding this intensity IP here. If you start changing this theta, try to understand this theta is going to change. From where to where this theta can change here, this is theta. Try to understand. This is theta. So what is the possible value of theta? Theta in this direction, if you change this theta, it will move from 0 to plus pi by 2. And in this direction, theta is going to change from 0 to minus pi by 2. So this theta here, it is going to vary from minus pi by 2 to plus pi by 2. This is the variation of theta. So by changing theta, whenever you are going to change theta, you are going to pattern on the complete screen. If theta is 0, then you are going to get that all these light waves, they are going to be focused here. If you are changing theta from 0 to plus pi by 2, you are going to get the intensity at different points on the upper part of this screen. ठीक है? If you change the value of theta from 0 to minus pi by 2 in this direction, you are going to pattern on this side. So now my objective is to find out this IP. My objective is to find out this IP. ठीक है? So now we want to find out that. Is it okay? Now tell me what will be the part difference between this ray 1 and this last ray. I'm saying this is nth ray. I'm saying this single slit is made up of n number of point sources. What I'm saying, I'm assuming let single slit, let single slit is made of is made of n number of point sources. N number of point sources. ठीक है? N number of point sources. So what will be the power difference between these two? So if the slit width is E This is E. Then if you draw a perpendicular from here to here, so what I'm doing, so this is suppose A and this point is B, then draw a perpendicular like this. So this will be the part difference. ठीक है ना, this will be the part difference बेटा. तो ये part difference होगा. And here this angle will be theta. Why this angle will be theta? Try to understand. This line is perpendicular to this, and this line is perpendicular to this. Angle between these two is theta, so automatically this angle is also going to be theta. This will be theta, and this angle is 90, so this is hypotenuse. What is this? So this will be what it will be. This will be E sine theta. This is going to be E sine theta. Try to understand. This will be E sine theta. So part difference between these extreme rays, ray number 1 and ray number n, is E sine theta. So what will be the part difference? What will be the phase difference between ray number 1 and ray number n? This will be 2 pi by lambda, 2 pi by lambda, and this will be E sine theta. E sine. N is very, very large. Try to understand. N is very, very large. So what will be the phase difference between two successive waves? These are n number of waves which are propagating in this direction. In between extreme rays waves, this is the phase difference. This is the phase difference between 1 and n. So what will be the phase difference between these successive two waves? That will be, you have to divide this by n. What you are going to do, you will divide this by n, and n is very, very large. So this will be the delta. So what is this? This is delta. You can write here, delta is the phase difference between two successive waves. Between two successive waves. Out of these n, between two successive waves, this is the phase difference. And how many waves are there? They are n number of waves. Now, n number of waves, they are moving parallel to each other. ठीक है, they are overlapping. Successive phase difference between these waves is delta. Can you tell me? Can you tell me what will be the intensity at point P? With the help of the lens, what you are doing? With the help of this lens, you are overlapping these n number of waves here. So what will be the intensity at point P? If amplitude of each of the wave, you can assume here that intensity of each of the waves is A. I'm assuming out of these n, they are identical point sources, so I can assume amplitude of each of the wave is A. So what will be the IP? Can anyone tell me what will be the expression of IP? I have done n slit interference experiment where n number of waves, they were overlapped at a point. And what was the intensity? Can anyone tell me? Can you recall? A, if you remember, I'm writing A, amplitude of a wave, sine n delta by 2. N delta by 2 divided by, this will be sine of delta by 2, and this is R. If you make the square of this, okay, if you make the square of this, that will be the intensity. So what I write here, this is the resultant amplitude at this point P. Okay, what will be the intensity? Intensity will be Rp square. Rp square. So this will be A square sine square n delta by 2 divided by sine square delta by 2. Delta by 2. ठीक है? Substitute this value of delta here. ठीक है? So what will be n delta by 2? From here you can find out what will be n delta by 2. That will be, if you multiply this by n, this n will cancel out. This 2 will also cancel out. So this will be pi e sine theta upon lambda. This will be, and I assume it as alpha. And I'm assuming this is suppose alpha. So what is alpha? Alpha is pi e sine theta upon lambda. So here, this what will be this intensity at point P? This will be a square sine square alpha divided by what it will be. This is delta by 2. If you look here, what will be delta by 2? Delta by 2, that will be 1 by n. ठीक है, 1 by n, 2 will cancel out. Pi by lambda, pi e sine theta upon lambda. And what it will be? This will be alpha upon n. Alpha upon n. And n is very, very large. It is 10,000, 20,000, 40,000. So this will be sine square alpha by n. Alpha by n. ठीक है, as alpha is very large. Try to understand alpha is very, very large, tending to infinity. ठीक है, tending to infinity. So this alpha by n, it will tend to 0. When it is tending to 0, this sine alpha by n in radians, it will be approximated. You can approximate it to alpha by n. This will be equal to alpha by n. So substitute this sine alpha by n as alpha by n here. Substitute this value of sine alpha by n here. So this will be alpha square upon n square. It will be alpha square upon n square. ठीक है? So here what I am going to write, IP, this will be a square sine square alpha upon alpha square upon n square. Alpha square upon n square. Take the n square here, so this will be n square a square, or you can write na square sine square alpha upon alpha square. And this will be IP. What it will be? This will be IP. Now what this Na will be? Try to understand. N is tending to infinity. And when n is tending to infinity, automatically amplitude will be very, very much diminished. So you will say that when n is tending to infinity, so this will be a point slit as small as possible. So this A will tend to 0. And when you multiply this type of quantities together, then from a mathematical theorem, this Na will be equal to some constant. It will be a constant. And we consider this constant as A. Later on we can define A, but right now this will be A. This will be a constant and I'm writing this as A. So what will be the intensity at point P? That will be A square sine square alpha upon alpha square. So this will be the intensity at point P. What will be this intensity? This is the intensity at point P. So this is the formula for single slit diffraction. For single slit diffraction, this is the formula for the intensity. So intensity on this screen at any point P, ठीक है ना, that is given as this IP at an arbitrary point IP. It will be equal to A square sine square alpha upon alpha square. And this alpha, it is theta dependent. Okay, remember this. This alpha is what? This alpha is theta dependent. So this is alpha. So alpha is a function of theta. Lambda is constant. Slit width E is constant. So what is variable here? As you are moving on the screen, this is theta. So here this intensity is a function of theta. So as you are going to move in the upward direction or downward direction on the screen, you are going to get different values of this intensity. You will get different intensities. So what we are having here, so here we are having a slit like this. It is illuminated by a planar wavefront. A planar wavefront is incident on it. And we get a intensity pattern over here. Okay, we are getting an intensity pattern here. And this intensity pattern is given by IP equal to A square sin square alpha upon alpha square. So here this pattern will be, again I am writing here, A square sin square alpha upon alpha square. What is alpha? Alpha is pi by lambda, and this will be E sin theta. E sin theta. ठीक है, if you plot this IP as a function of theta, then you will get this type of pattern on the screen. Here on the screen, you are going to get this type of intensity pattern. This type of intensity pattern you are going to get on the screen. This will be I, this will be 0. And here, corresponding to theta, you are getting different intensity point. So this type of pattern you are going to get in single slit diffraction pattern. Here you can say this is this is theta. Corresponding to theta you can say, or you can say alpha is there. This is alpha. And alpha is a function of theta. Here this is alpha, and alpha itself is a function of theta. Okay. Now question is, we are getting the central maxima. This is called as this one and this one. This is first order maxima. This is second order maxima. This is minima. So now I want to find out the condition of minimas. So my first objective is to find out the condition of minima, as well as I want to find out the positions or conditions for maximas also. So here our objective first is to find out the maximas and minimas, position of maximas and minimas. Okay, so for this purpose we can use this expression. Okay, so first is we will start with theta is 0. If you are choosing theta equal to 0, so first case here, suppose you consider theta equal to 0. So where will be the point corresponding to theta equal to 0? This will be the point. Okay, this will be the point. So if theta is 0, then alpha is 0. Theta is 0 is saying that alpha is 0. Alpha is 0. And this is sine alpha upon alpha. What is this? This is sine alpha upon alpha. Okay. So if I find out intensity, okay, corresponding to theta equal to 0, then it will be A square. This will be limit. Okay. This will be limit theta tending to 0. Or when theta is 0, it will be alpha. Limit alpha tending to 0. And this will be, you can write it as sine alpha upon alpha and make the square of this. Square of this. So this will be 1 beta. What is this formula for this? This is 1. So what will be the intensity at central point O corresponding to theta equal to 0? This is A square. ठीक है, A square. So how can you define A? A can be defined as that the intensity at the central point on the screen will be A square. ठीक है, so intensity at the central point here, this intensity is how much? This intensity is A square. This is A square. This intensity is A square beta. ठीक है, this will be first thing. So at the center, you are going to get this intensity, and this is corresponding to this point. So central point is corresponding to this theta equal to 0 and alpha equal to 0, and this is maxima. You call it as central maxima. This is called as central maxima. So this is the intensity at the peak or at the central maxima. This will be the intensity. Is it clear up to this point, beta? Second, second, you want to find out the positions or condition for minimas. Conditions for minimas. Condition for minimas. What will happen at minima? At minima, I will be 0. Intensity will be 0. So intensity I will be 0 here. ठीक है, what is I? I is this A square sine square alpha upon alpha square. So from here I can write if I is 0, then sine alpha upon alpha equal to 0. ठीक है, so how can it will be 0? It will be equal to 0. What it is saying? It is saying that for minima this sine alpha should be 0, but alpha is not equal to 0. Alpha should not be 0. If alpha will become 0, you will be here. You will get the position of central maxima if you are choosing alpha equal to 0. So you are leaving this. Alpha is not equal to 0. So what will be here? Alpha. So it will not be pi. It may be pi. It will not be 0. Try to understand. It will be pi, 2 pi, 3 pi, 4 pi. At all these values, ठीक है ना? At all these values, you are going to get a minima. So you will get minima at all these values. So I write it as n lambda. So I write alpha equal to n pi. Alpha equal to n pi, where n is equal to 1, 2, 3, like this. N is equal to 1, 2, 3. It cannot be 0. It cannot be 0. ठीक है? So what is the condition? Alpha is equal to n pi. Substitute the value of alpha. Alpha is pi by lambda, and this will be E sine theta. And this will be equal to n pi. So this pi is going to cancel out. It will be E sine theta. This will be equal to n lambda. This will be n lambda. So E sine theta is equal to n lambda. So this is the condition for minima. So this is the condition for minima. You have to remember this. Remember this, n will be 1 minima. So first order minima will be there. You can say plus minus 1 on both sides. It may be plus minus 2 for second order minima. Plus minus 3, it will be like this. So you have find out the position. This is n equal to 1. You can say this is n equal to minus 1. You can say this is n equal to 1, n equal to minus 1. These are first order minima. Just minus sign because here theta angle I'm considering negative. Negative. So this will be corresponding to n equal to 2 second order minima. Here this will be corresponding to n equal to minus 2. There is no difference between them because I am considering this angle as theta. Try to understand in anti-clockwise direction. I am considering theta as positive. In clockwise direction, I am considering theta as negative. That's why I am writing n equal to minus 1, minus 2 like this. Otherwise, there is no difference between these two. This will be n equal to 3. This will be n equal to minus 3. So they are minimas. They are diffraction minima, single slit diffraction minimas. Next question is, what will be the condition? I will also find out the position of these minimas. I will also find out the position of these minimas. Okay? But first, okay, before moving further, uh, I will first I find out the position of first minima itself. This is first minima. So what is this? This is first minima here. So this is first minima. You want to find out this angle. Okay? You want to find out this angle theta. You are getting this theta 1. So you are getting first minima at theta 1. So they can ask you to find out the angular position of the first order minima. So if they ask you what will be the angular position of first order minima, so what it will be? First is angular position. Angular position of first minima. First means n equal to 1 minima. This will be E sine theta 1. This angle is theta 1. And this will be plus minus 1 and lambda. So what this theta 1 will be angular position. Theta 1. This will be equal to कितना होगा बेटा ये? This will be lambda by E plus minus, or I can write this will be sine inverse plus minus lambda upon E. This will be the angular position of the first order minima on both sides. This will be the angular position of first order minima on both sides. Okay? So try to understand here this theta 1 you have find out. If I ask you what will be the angular width of this central maxima, this is central maxima. Then angular width of the central maxima will be this one. This will be the angular width. So how much will be the angular width of the central maxima? This is minima to minima. So this angle 2 theta 1, this is also theta 1. This is also theta 1 with negative sign, but this angle will be 2 theta 1. Okay, this is theta 1 plus in this direction minus theta 1. So what will be this angle? This will be 2 theta 1. So what will be the angular width of this central maxima? What is this? This is central maxima. Central maxima. Okay. So what will be the angular width of the central maxima? Angular width of central maximum. Of central maxima. कितना होगा? That will be 2 theta. 1. So that will be equal to 2 times sine inverse plus minus lambda upon E. This will be. Now, they can ask you what will be the linear width of the central maximum. Now they are saying you to calculate the linear width. Okay, you want to find out this width from here to here, from minima to minima. You want to find out this. So how much it will be? ठीक है, ये कितना होगा बेटा width, this linear width of the central maxima. Try to understand this distance will be roughly the focal length of the lens, or you can say they are going to provide you the focal length of the lens, or they will provide you the separation between the single slit plane and this screen. So this may be F or D, they may write. Okay, so what will be this distance? Try to understand. Here this is D from here to here, and this is, you can say, you want to find out this. So tan theta 1 will provide you. Suppose this is some, you can say, Y. Okay, this will also be Y. So this will be Y naught, Y naught. This will be 2 Y naught. So this tan theta 1 will be Y naught upon D. So what it will be, tan theta 1, I can write here, tan theta 1. This will be Y naught upon F or D. Or you can say Y naught is equal to D tan theta 1. D tan theta 1. Theta 1. From here you can find out theta 1. They will give you some value, you will find out this theta 1. It may be 15 degree, 20 degree, 30 degree, something like this. So this Y naught will be this. So what will be the linear width of the central maximum? Linear width of the central maximum. Of the central maxima. This will be, you can say, W naught. That will be equal to 2Y naught. So this will be 2 times D tan theta 1. So in this way, you can find out the width of the central maxima. They can ask you to find out the angular position of the first minima. They can ask you what will be the angular width of the central maxima, or they can ask you to find out the linear width of the central maximum. Next, what will be the position of the, yes, beta?
सर एंगुलर विथ मतलब वो पिक्चर में थोड़ा सा एक बार दिखाइए ना.
Yes, beta. Angular width means this width. Try to understand this width. It is making some angle at the central point of the slit. Okay, this is slit here. So this width, this is the angular, this is the linear width, or this is, you can say, this is the width of the central maxima. This is making some angle here at the central point of the slit. So this angle, this is called as the angular width of this central maximum. Okay, is it clear what I am saying?
हाँ हाँ सर
ठीक है.
ठीक.
Next, I want to find out the position of this second order minima. And next, I want to find out the angular width of this first order maxima. This is what? This is first order maxima. First order maxima. So now we have two objectives here. From this, you want to find out the angular position of this second minima, second order minima, as well as you want to find out the angular width and linear width of this first order maximum. This is our objective. So here, what will be the position here? Position of angular position. Angular position of first order, yes, second order, of second order, ठीक है, of second order minimum, n equal to 2 minima. This is simple to find out. You can say here, ठीक है, this is second order minima. So here I will draw this line. A little bit just. So what is this? This will be theta 2. So this is going to be theta 2. ठीक है? This will be theta 2. So theta 2 you want to find out. So what will be theta 2? Theta 2 will be E sine theta 2. E sine theta 2. This will be plus minus 2 lambda on both sides. So theta 2 will be sine inverse plus minus 2 lambda upon E. This will be the angular position of second order maximum. Minima, sorry, not maximum. Now, next, you want to find out angular width of first order maximum. Angular width of first order maximum. Not central, this is first order maximum. Maxima. So now you want to find out the angle that is subtended by this width. This is the width here. So here, this is the width of the first order maximum. So what angle it is subtending here at the center of the slit, that is this. And how much this will be? This will be theta 2, this will be theta 1. So this will be theta 2 minus theta 1. This will be theta 2 minus theta 1. Okay? So what will the width of this? That will be equal to theta 2 minus theta 1. So I just write sine inverse. I'm not writing plus minus both, only one. 2 lambda upon E minus sine inverse lambda upon E on one side. On the other side also this will be the width. So I'm writing delta theta 1. This is delta theta 1. Okay? Here this width, this angular width here, where I have written 2 theta, you can write it as delta theta 0. Delta theta 0. Angular width of the central maximum. So this will be. Okay? So you have to understand this. They will not ask you the linear width, ठीक है ना, because it will take a lot of time. So that type of question will not be there. ठीक है? So this will be. Is it clear? Is it clear
Sir,
up to this point? Yes, beta.
sir, I have one doubt.
Okay. बताइए बेटा
Sir,
please.
you have told that means if we are taking n number of slit and n tends to infinity, then sir, why small a tends to means zero? I can't understand that point.
Okay. So if you are having this slit, ठीक है, intensity of the light that is coming from it is I. ठीक है ना, that is I. So if you make it half, what will happen to its intensity? Its intensity will become I by 2. If you convert it into 4 parts, what will be the intensity? That will be, you have divided, so this will be this. Okay? If you convert it into n number of parts, then what will the intensity that is coming from individual parts? That will be I by n. Okay? So this will be, you can say, I by n. So what will be the intensity if n is tending to infinity? Try to understand, if n is tending to infinity, very, very large, then this I by n, that is the intensity that is coming out from each individual part. Here, 4 parts are there. If you divide it into n number of parts, then from individual parts, what will be the intensity of light? That will tend to 0 if n is tending to infinity. So if intensity is tending to 0, it means its amplitude, you can say amplitude is going to be very, very small. So A is going to be very, very small. So that's why when I was using here this A, okay, I'm saying the light that is coming from here, then amplitude of each of the wave is A, and this amplitude A will be very, very small. As you will increase the n number of a number of point sources, as you are considering more and more point sources, you are considering, this A will become lesser, lesser, lesser. And if n is very, very large, like 10 to the power 4, 5, 6, automatically this A will be very, very small, as small as you can think. That's why I'm choosing n is tending to infinity. N is tending to infinity, so this A is tending to 0. So one is tending to infinity, another is tending to 0. If you multiply such two type of quantities, if you multiply them, you will get some finite number. This is a mathematical theorem. I'm not going into that, but you can look at Google or somewhere. You can find out that theorem in your mathematical physics book. Somewhere you will get surely. Okay? So that's why I'm writing n into a, that is a constant, and I'm representing that constant by capital A. Is it clear what I'm saying, beta?
Yes, sir, I got.
So this is. So here we find out the angular width of the first order maximum. Next question is, what is the condition for maximus? So next is condition for maximus. Condition of maximus. So this I will be a square sin square alpha upon alpha square. ठीक है, for maxima di by d alpha, alpha or theta is variable, so di by d alpha, ठीक है, that will be equal to 0. So what it will be, you can write this is, you can write it as a sin alpha upon alpha and whole square of this. This will be 2a sin alpha upon alpha, and this will be d by d alpha sin alpha upon alpha, and this will be equal to 0. This is a constant. If you make it 0, try to understand, if you are making this term 0, then what you are going to get? You will get the condition of minimus. So when I am equating this part equal to 0, this will give me the condition of minima. So I'm not considering it now. I'm equating this equal to 0. So what will be the differentiation of this? This will be alpha square, alpha square. This will be alpha, and differentiate this sine alpha. This will be cos alpha, minus this will be sine alpha, and it will be like this, and it will be 0. ठीक है ना? It will be 0. ठीक है? So equate this. So what you are going to get? You will get alpha cos alpha. That will be equal to sine alpha. So what will be tan alpha? Tan alpha, that is equal to alpha. So this is the transcendental equation, or you say the condition for maximus. This is called as the condition for, this is a transcendental equation or condition of maximus. ठीक है ना? You are going to say that this is the condition of maximus. Is it clear? Hello.
Yes, sir.
So this will be. Next is, if you are writing this tan alpha equal to alpha, what will be the value of theta corresponding to, or what will be the value of alpha at which you are going to get the maximus? So basically, this is a very difficult equation to solve. What you have to do, you are going to plot this, and from the plotting, you are going to find out the positions for which the alpha you are going to get, the position of alpha or values of alpha at which you are going to get the maxima. So how you can solve this? How can you draw this? So for this we use very simple method. This tan alpha equal to alpha, equate these equal to y. So now this equation can be written in in the form of these two equations, y equal to alpha and y equal to tan alpha. Now plot these two equations, and wherever they are going to intersect, that will be the solution, that will be the point that will provide you the value of alpha corresponding to maximus. Okay? So you are going to plot it here. So this is y-axis. This is alpha. Alpha. You want to plot y equal to tan alpha. So first here, this is the line corresponding to pi by 2. Here, this is corresponding to pi by 2. This line is corresponding to pi by 2. Then there will be pi here, and then there will be 3 pi by 2. So this line, because this tan alpha, it is going to show asymptotic behavior at these values. So this will be 3 pi by 2. Then there will be 2 pi here, and then there will be 5 pi by 2. 5 pi by 2, like this. 3 pi, this will be pi, 2 pi, 3 pi, and there will be 7 pi by 2. 7 pi by 2. If you plot this tan alpha, what type of plot you will get? At 0, at alpha equal to 0, this tan alpha will be 0, and it will be where it will tend to infinity like this. It will be like this. Okay? It is going to be like this. And again, at tan pi, it will be 0. And here, it will be negative value, and then it will be something like this. Next, you are going to get this type of plot you are going to get for 10. This is the plot of tan alpha. So here on the y-axis, this is the plot of tan alpha. Now second equation is y equal to alpha. So draw that y equal to alpha. If you plot, it will be something like this. So where this line is intersecting, one of the point is this, second point is this, Third point is this. So where these two curves, these two plots, they are intersecting for these values of alpha. ठीक है? This will be 1.46 pi 1.46 pi, then it will be 2.46 pi nearly, then 3.46 pi, roughly like these values. They are going to, basically these two curves, they are going to intersect here. ठीक है ना? So this is 3.4 something. 3.4 value, this may not be 6, but roughly this value will be there. If you want to approximate, then you will find out that will be 3 pi by 2. That will be 5 pi by 2. That will be 7 pi by 2. Like this. So these are the values of alpha where you are going to get maximas. Okay? So this is the condition for maximum. Either this one or this one. So here at these values of alpha, you are going to get the maximas. Now come back. Here intensity is written as I equal to A square sine square alpha upon alpha square. So what will be the intensity of the central maxima? Central maxima, intensity of the central maxima will be A square. ठीक है? Because here alpha is tending to 0. Try to understand, here alpha is 0, is tending to 0. So I naught, it will be A square. For alpha equal to nearly equal to 3 pi by 2, you will get first order maxima. So what will be I1? I1 will be A square sine square 3 pi by 2 divided by 3 pi by 2 whole square. ठीक है? 3 pi by 2 whole square. You are going to get this. How much you will get? You will get A square by 22. Nearly A square by 22. 22. ठीक है? Second order maxima, this will be at alpha equal to 5 pi by 2. So what will be I2? I2 will be A square sine square 5 pi by 2 divided by 5 pi by 2 and whole square of this. So nearly it will be A square upon 61. How much it will be? This will be A square upon 61. ठीक है? For alpha equal to 7 pi by 2, you will get next maxima. So what will be I3? I3 will be A square sine square 7 pi by 2 divided by 7 pi by 2 whole square. So this will be approximately equal to A square by 121. 121. ठीक है? So what will be the intensity ratios here? That will be I naught, central maxima, first order maxima, second order maxima, third order maxima. ठीक है ना? They will be equal to, that will be 1 is to 1 by 22, 1 by 61, 1 by 121 or something like this and so on. ठीक है ना? And so on. ठीक है? So try to understand, if they ask you, they will provide you a data, complete data, and they will ask you find the ratio of second order maxima to first order maxima. ठीक है? Second order maxima to first order maxima. So this is second order maxima. This will be 1 by, or you can say This I2 is A square upon 61. I2 by I1. It should be I2 by I1. So A square by 61 divided by A square upon, there is no need to calculate. So this will be simply 21 upon 61. So if they ask you the ratio of intensities of the first order maxima, second order maxima, or second or third, ठीक है, or with zeroth, they are comparing, then directly from this relation, you can write that ratio of intensities. You can directly write the ratio of intensities. Is it clear? Hello?
Yes, sir.
Yes.
Now, last point is here. So you are getting this type of pattern of single slit diffraction. This is the last point here. So what type of pattern you are having? You are having this type of single slit pattern. This is 0. This is theta 1. This is, you can say, minus theta 1. And what is theta 1? Theta 1 is sine inverse lambda upon E. Okay? Here this will be sine inverse minus lambda upon E. Now, if slit width is reduced, if E is becoming narrower, is becoming narrower, then what is going to happen? You are going to tell me. Okay? If slit width is becoming narrower, what is E? E is slit width. Try to understand in this simple. This is E sine theta and this is plus minus lambda. If you are making it down, it is becoming less and less. Right hand side is constant. Try to understand lambda is constant. So if E is going down, theta is going to increase. So what will happen? Then this central envelope, central maxima, ठीक है ना, it will become wider. What will happen? If you are narrowing the slit, then central maxima will become wider. Then central maxima will become wider. ठीक है? So here I have discussed all the type of possibilities they can ask. ठीक है? All possibilities from which they can design a question related to single slit diffraction. In the next class, first I will discuss 4-5 questions and then I will start discussing double slit diffraction. If you know single slit diffraction, very easily you can understand double slit diffraction. So in the next class, I will complete double slit diffraction also. Up to double slit diffraction in the next class I will complete. Most probably it will be tomorrow. Okay? So I will try to complete double slit diffraction tomorrow. Okay, beta.
Thank you,
Thank you,
sir.
sir.
Welcome,
Slides,
beta.
please,
Okay.
sir.
Yes, beta. Please. This is the first one. Second one. Third. Fourth. Fifth. Sixth. Seventh. 8 9 ठीक है ओके बेटा थैंक यू वेरी मच
Thank you, sir.
वेलकम बेटा